All right. Howdy, everyone. Happy Thursday. Um, Sorry that I swapped around which week that I'm hosting my session. Turns out it's hard to do Mondays. Um, so we'll be doing Thursday for the rest of this class. Um, Today is day one of week two of Task Manager API and using MongoDB/Mongoose. Um, I'm gonna repaste the sign-in link for anyone who hasn't done it yet. Just make sure you do that before you leave. Um, Today, I am happy to talk about anything that you guys have questions, comments about. I don't think there's any new content in week two. I think it's just like more project stuff to do for this task manager, but I could be wrong. Someone yell at me if I'm wrong. Um, So feel free to ask any questions, anything you want clarification on, anything you want to talk about. The floor is open. All right. Well, hearing nothing right now, I think what we'll do today is we'll take our ice cream shop demo and we're going to, instead of persisting our ice cream in memory, which we said last time we were meeting, uh, resets every time you restart the server since it's just recreating a bunch of variables in memory. Um, the link to the Notion page should be in the Slack, but I can copy it one more time. There you go. So we're going to take our ice cream, which we're currently persisting in memory, and resets every time the server restarts. And we're going to save it into MongoDB, into a database, so that even when our server stops and restarts, our database is still consistent. And we have an actual inventory that doesn't change. So we'll write a little bit of MongoDB client code in order to interact with MongoDB. Um, we'll very briefly talk about MongoDB. There's a really great article on the MongoDB docs that I've linked for you here that talks about SQL databases versus no SQL databases. MongoDB is a no SQL database. A lot of people like MongoDB just because it's very friendly to work with. SQL uh, structures all of your data in tables that have a fixed row and column set. So you add more rows to the table, but every row has to have a certain number of data elements that go into a column. It's very structured. It requires a lot of planning in advance to make sure you're not shooting yourself in the foot. But SQL is like an industry standard. It's been around forever. NoSQL databases are a more recent thing, although certainly they've been around for a while at this point. MongoDB is definitely the most popular, but there are other options. And in MongoDB, all you're doing is persisting data in a document, and it can be in whatever form you want. In general, when you have the equivalent of a table in MongoDB, which MongoDB calls a collection instead, which is basically just like a bunch of documents collected together. Those generally, you probably want them to all follow relatively the same schema, but it's a lot more extensible. You can like have some fields in some documents, but not in others. A lot of people use it with JavaScript in particular. You'll hear stuff like the LAMP stack or the MERN stack. These are all just technologies that frequently get used together, and MongoDB is in both of them. So we're going to use MongoDB for no other reason other than it's a cool technology that's worth learning. SQL is the same way. I use MongoDB very heavily at work just because I have a team that works on a project that is a distributed system, meaning we have a lot of different small little services that all interact with each other, and they're all running in separate Kubernetes pods. They're all running like totally separately on different hosts. And it comes with a number of challenges and also with a number of benefits. But one of the benefits is that um, our database can be sort of split over multiple different hosts a lot easier and horizontally scaled, meaning add more servers that are able to control your database rather than vertical scaling, which means my database is running on one host and I'm just giving that host more computing power or more memory, which you can do up to a theoretical limit of, how fast you can get your processor. So um, it fits very well, MongoDB in a distributed system like this, which is something that this article talks about. Feel free to go more in depth than that or ask any questions. Um, but it's also just something that people like to throw into a lot of tutorials and stuff. So we're going to use that here. We're also going to use Mongoose, which is I guess it's like a library for modeling objects that get put into MongoDB to provide a little bit more structure. And it just provides a lot of conveniences for interacting with MongoDB. You could certainly do it with other MongoDB driver packages, but Mongoose comes with some extra really cool stuff, like modeling a specific object that has a bunch of different fields and what those fields are and validating those fields. You don't have to do all of that yourself. It gets abstracted away for you, which is why a lot of people use Mongoose. We're also going to use .env, which is a library that allows you to load environment variables. So an environment variable is a piece of data that's stored in your um, like in your shell that is executing, shell meaning like terminal in this case, or it's stored if you were to like SSH onto a remote host. So not your computer, but if you were to SSH, which like creates a session on a remote server and lets you pretend like you're on that server. You can use environment variables that belong to specifically that session. Um, and similarly, what often ends up happening is when you deploy your application into production, that's going to stick it onto a host somewhere, either one that you own or your company owns, or you're going to stick it in the cloud somewhere so that you don't have to actually like purchase a physical computer in order to run your application, which not everyone can do. So in any of those cases, we want to be able to provide like variables to configure our application that exist in that environment. And so we can configure environment variables. I should not have done that. That are loaded into our application. So I could create an environment variable on my terminal by exporting something equal to foo. So now I have an environment variable in this terminal called something, and the value is foo. And from my terminal, I can actually prove that I have this variable by echoing it back to the console, which prints me the value of that variable. Now, if I were to start a new terminal and I do the same thing, I echo something. Now it's empty because that environment variable only exists in the environment of this shell session, this terminal window that I have open. So we're going to use environment variables to load in some configuration for our application. In this case, we're going to use it to load in a lot of like secrets or things that are environment specific. So maybe in one place, I want to point my application at a development database where if it goes wrong, it doesn't really hurt anything. And then in my real application, I want to point at a production database instance where if that goes wrong, then it's going to be a bigger problem for our customers. So in that case, this is something we need to configure about our application. We can't just like write it, hard code it somewhere up here. So instead, what we're going to do is we're going to load it in whenever we run our application. So that's what we're going to do. We're going to create this .env file with this Mongo URI environment variable and point it at our MongoDB that we're going to be running locally on our computer. All right, that was a lot of explanation for not writing any code. So let's get into the writing the code part. I am going to jump into our application, which is under demos and ice cream shop. If you already have these pulled down, make sure you git pull on the repository. The repository being this Kangaroo demos. I did rename one of the folders. It previously was Express demo, but we're just going to keep using it over and over. So I wanted to name it something a little more useful. And make sure you have all the changes in this ice cream shop that we've done in the past couple of weeks, because that's where we're going to start. All right, so let's maybe start by making sure that we have a MongoDB instance that we can use. If you don't have anything, one thing that you can do is you can use MongoDB Atlas, which is generally not too hard to set up. Maybe it takes a few minutes. I'm not going to do this today. We're just going to run it locally on our computer, but this is worth knowing that this is a cloud-hosted database, which means MongoDB, the company, will host your database for you and do most of the problematic setup, and it'll always be available. So this takes away a lot of the difficulty from you. We're not going to do anything really complicated with our database administration, so we don't really need this in this particular case. We're just going to run it locally on our computer and just use the out-of-the-box setup. But if you were to use MongoDB for like a real project, you probably want someone who knows how to make your database as secure as possible. And a lot of us just don't have that expertise. So using MongoDB Atlas allows them to do the hard work for you. But again, we're not going to do that. Instead, we're going to install MongoDB directly. I am following the MongoDB Mac setup guides, which I can do using Homebrew. If you have a Windows machine, it's probably going to be a little bit different. So you're going to want to jump on there and look at what's going on. But for MongoDB Community Edition on a Mac, we need to make sure that our Xcode command line tools are ready to go by you can do it through your Mac terminal, or if you have the App Store down here, you should be able to do it there as well. And then the Homebrew package is something that I use literally every day to install tools very easily. Homebrew is the best. Make sure you have Homebrew. You can follow these installation instructions in order to do that. And once you have those two things, then we're just going to install MongoDB according to their instructions. I already have this, so I'm not going to spend a bunch of time on this, but we would do brew tap MongoDB/brew. And this is downloading basically like an index of all the MongoDB and database tools that you can install with Homebrew. And once we have this, we're going to do brew update, which is going to take that index and make sure it has all the most recently released versions. And then we're going to brew install MongoDB community. I've installed 8.0 as they tell me to by doing this specific version. I think you could just install MongoDB community and it'll pick a version for you. Either is totally fine, not a big deal. And what this is going to do is it's going to install the whole application for us. And we're going to get a couple of different binaries. So we have a MongoD server, which is sort of like the underlying process that's actually running it. We have MongoS, which is if we had a really complicated database that had a lot of different instances in different physical regions, we might create what's called a sharded cluster, where we split up like which instance is responsible for specific pieces of data depending on a specific field. So if my object said that it's an object that belongs to the US shard, then the US instance of my database is going to hold that data and be the primary source. Whereas if my object says, oh, I actually belong to Amsterdam, which is something that we do at work. We have an office in Amsterdam, we have an office in the US, and there's data that belongs in both places. Well, it's going to route whatever interactions with MongoDB to the Amsterdam database, which is a lot closer than the one in the US and requires less network latency trying to get across the ocean. We're not going to use this. Don't worry about this. We're not doing anything sharded. That's way more complicated than anything we need. And then it also installs the MongoDB shell, which allows us to basically create a terminal session where we can interact with the MongoDB database. We're not actually interested in using this shell. That's more complicated than anything we need right now. What we're going to do instead is we're going to use MongoDB Compass, which I also already have installed. And MongoDB Compass, which I'm going to open from my applications window, if I still have it. Here we go. MongoDB Compass is a tool created by MongoDB that allows you to just like look at all of your databases really conveniently. We might have multiple databases and we can save connection information so we don't have to like constantly remember where everything is and what all the credentials are. And I can see every single thing in my database pretty conveniently through a UI, and I can interact with documents directly. So I have my test database where I have my ice creams. These are all my ice creams in a document. So each document has structure to it. And I could like delete these if I want to. I can try and search for a document with flavor vanilla and filter them down so that only that is showing. There's a lot of really cool things you can do with MongoDB Compass. We're going to use this just to validate that our stuff is actually working. But those are the two main pieces that we need. Um, and if you're using MongoDB Atlas, you probably don't need either of them. You just need to set up a MongoDB uh, application in Atlas, and there should be a UI for you to interact with it without having to download MongoDB Compass. So feel free to stick with that if you want to. I'm realizing now that the burden of setup of MongoDB is probably going to mean that it's going to be hard to follow this, so I'm very sorry. I should have planned that out in advance. Um, but what we can do once we have MongoDB downloaded is we can just run the brew services start command, which is going to start up our MongoDB instance running in the background, and it means that we're actually able to connect to it. So it's already started. If I were to stop this, and then I go back into my MongoDB Compass, I'm going to disconnect from my server and try and connect. Well, now it's telling me that the connection is refused because it's not actually running. So if you can't use MongoDB Compass to get into it, then make sure that it's started up and you have the right credentials. Successfully started, and there we go. My connection info is just saying that it's running on my local machine. This is the default port where it serves your database. And you can edit that, but we're gonna leave that alone. Okay. Still a lot of explaining for having not written any code. So we're gonna go to our master branch. We're going to git pull and make sure we have everything ready to go. All right, cool. So this is our application where it currently stands. We can we start this up. We can buy our ice cream. We can buy vanilla, 2 scoops, and it goes down to 1. We cannot add to our inventory yet. And if I stop this and I start it back up and I refresh, this resets to 5 since it's not persisted. All right, so let's install the things that we need here in order to make this work. We're going to install save dev.env, which is the package that we're going to use. I don't know what the hell happened here. This is what we're going to use to load our configuration values. We're going to npm install Mongoose. We don't need .env in a production environment. This is really only for running our server locally. So we're installing that as a dev dependency, whereas Mongoose is the library that actually lets us call MongoDB, and we need that all the time. So we're going to install that as a regular dependency. I think that should cover us. So what we're gonna do is we're going to first make sure that we have our config that we can actually load up. So we're going to create a .env file, and let's call this foo equals bar. So this is our variable, this is our value. We're just going to load this up from our app.js and make sure that it actually works. So we should be able to import from .env config. So we're just going to import this config method from .env, which we can provide options, but it's just going to load that .env file. And then all we have to do is call config in order to execute that function. And now we have all of our variables loaded into our environment. So this is specifically for if we have a deb dependency. And what we're going to do is we are going to console.log process.env.foo, which is what we called that variable, just to prove that this works. So anytime we want to get an environment variable, we call process, which belongs to NodeJS and is information about the process that is actually executing your application. And then env to indicate we want environment variables, and then we can grab the variable that we want. This will not probably autofill for us since the package doesn't know what environment variables are available. So whatever you put in here, it's okay if it doesn't autocomplete. Now if we npm start, we print bar down here, which is great. All right, we're going to take that out and we're going to put something more useful in. And let's call this our MongoDB URI. And this is a pretty static URL, which is going to work in most cases. And we're going to connect to our local host, 21017, I think is the port. Maybe it'll tell us further up here when we start. MongoDB. Just want to make sure I have the digits in the right order. 27017 is what we want. 27017. Cool. So this is just the port that it chooses by default. When we're actually managing our application, we could change that port. If you're using MongoDB Atlas, then I think there will be a button somewhere where you can like get connection string, and it's gonna say something other than localhost. It's gonna like have some actual URL to MongoDB Atlas and a different port and maybe some extra stuff at the end. But if we're running it locally, all we need is this localhost and the port. And we are going to use Mongoose to connect to our database. So Mongoose as a package, let's check what all we can actually use here. We're going to use this connect method, which is the method that opens a default connection to MongoDB. Notice that this returns a promise. This is asynchronous because it might take a long time to connect. It might be very fast. And we provide the URI that we want to connect to, which is that thing that we just put in process.env, Mongo URL. Oops, we said Mongo URI. And then once that connection is completed, actually, it doesn't look like there's a callback. It just provides connection options, which we don't care about here. All right, well, this is a promise. So we can either async await this using then, or we can do try catch. I personally would rather use a try catch here. And we're going to try to connect. We're going to await our connection. And if we have an error, we're going to console.error. What is our error? And once this Mongoose connection is finished, then we know that our server is up and running. And we'll go ahead and stick this in our try catch. Actually, no, we'll leave it outside. So now that our server is running and MongoDB is connected, then we're going to listen on a port for our server. So if I npm start here, invalid scheme. Oh, it can't be HTTP. It's got to be MongoDB. I see your question. You could just give me 2 seconds. All right, so we need this MongoDB up here. This is like the scheme of how we're going to exchange data at this particular URL. In this case, MongoDB has come up with their own scheme for exchanging data, as opposed to making an API request, which uses HTTP or HTTPS as the scheme. This specifically is using MongoDB. So let's try it again. And now our server is running on 3000 and it's connected and we are basically all good. Great. And we've connected to MongoDB. All right. There's a question. Go ahead. Ask your question.
Looks like I missed when you installed Mongoose. Could you show your packages on file?
Yeah, no problem. All we did was npm I mongoose.
Mhm.
And then down here for .env, npm I save dev.
Okay, thank you.
Yep. Everything else we should already have. It's just those two specific things that we need. All right. Step number 1, connect to Mongoose. We've done it. Step number 2, let's actually use it for some cool stuff. So right now, our ice cream exists in this controllers package defined in a static array. This array is why it resets, because every time the server starts up, it's going to redeclare this array in memory with these exact values. As my application progresses, I can update these values, but when the application stops, that memory gets cleared away and we no longer have access to it, so it'll redeclare it. So we're going to instead declare what is an ice cream in relation to our database, which we already have done it here since I was testing this out earlier. We're going to drop this collection, which gets rid of it, and we're going to start from scratch. All right, let's go create a models folder, which is where we're going to define all of our types. And in this case, we're going to declare an ice cream type. And we're going to use mongoose dot schema. Schema, that's a wildly unhelpful tooltip. If anyone has any idea what the hell's going on here, I would love to know. So we're gonna not trust that, and instead we're just gonna go look at our documentation to make sure that we know what the syntax is. There's lots of great examples on Mongoose. I end up referencing this all the time. But essentially what we're going to do is we're going to use this schema type to define what our database objects are shaped like. So every ice cream is going to have the same set of properties. And I can declare what are these properties, what are the values of these properties, and a bunch of other really cool things as well. So in this case, this is a title field, and it is always going to be a string. We have comments, which is an array of objects where each comment is a string body and a date when it was posted. We have a date type where it is a chronological date and it has a default value. So if I don't save a date value when I'm creating a new instance of this object in my database, it's going to just use whatever the current type, whatever the current date is as the default. Other cool things we can do, we can have fields that are themselves objects with other fields inside of them. So this is a metadata field and it has votes and favorites on the inside. So this schema is like a blog post where someone could vote for your post being good or favorite it if they really love it. And once we have this schema made of all these different types that we can use, we're going to create a model which converts the schema into a model. If we look at the Mongoose model type, a model is a constructor where I can create in my database a document of this particular schema, following that schema. So we're going to take this model function, and then we're going to export the constructor for these models. So this is a function. Um, sorry, it's not a function. It's an object constructor. We haven't talked about JavaScript objects, but um, basically, this is a constructor, so every time I call this, it's going to create a new instance of something. And then we're going to pass in all of those fields that we want that adhere to our schema, and it's going to go into our database when we tell it to update or replace a document or insert a document. And we're going to stick that model into our database using the save function or insert or a whole number of other things that we'll talk about a little bit. All right, let's do that. So we're going to take our schema definition. We're going to copy and paste this just as reference, which I personally like doing if I have some code that I know I'm generally going to follow, but I'm going to modify it a little bit. Actually, we don't even need to comment it. So we have our schema. We're going to call this ice cream schema, which is going to create a new ice cream document. And we're going to fix up these properties. So what do we have right now? We have a flavor, we have a number of scoops available. Um, we can start with those. Our flavor is type string require true. So require indicates, oops, um, did I mess it up? I thought there was a require function, but maybe it's something else. Required option. Okay, that's what I thought. It just wasn't, um, it's not completing this for me, which kind of sucks. Actually, I think that's why. Nope. All right. Well, this is partially why JavaScript sucks sometimes in that it doesn't really give you a lot of really helpful um, auto completion or like tooltips if you hover over something to try and understand what it is. Similarly, like if I write required here, it's not telling me that this is a valid property, even though it is. Um, in a lot of other languages, even TypeScript basically like solves the problem of JavaScript where as you're writing it, you never really know if something is correct or not until you actually run it. I would love to talk about TypeScript earlier in the course, but we don't do that. So we'll talk about that later. Um, but anyway, we have our scoops, which is type number. We're not going to make this required because we do want this to be able to be 0. But let's set our min value to be 0. So we cannot have anything less than 0. All right. So our number type, we have validators for min and max. Um, so we cannot save a document that has less than 0 scoops, which wouldn't make any sense anyway. Let's also just add a description here of type string, just for fun. We're not actually going to really use this, but we'll keep it around anyway. And then we're going to create a model. And this model is going to be named ice cream, and our schema is our ice cream schema. And we're going to export default this created model. All right, so what are we going to do with this? Well, what we're going to do is we're going to go into this controller section. We're going to take out these flavors, and we're going to use Mongoose instead to get whatever is in our database. So let's go ahead and do it. Mongoose. Actually, no. We want to import our ice cream model. And we are going to try and find a document of this model. So this model is a convenience of focusing um, either queries to the database or updates to the database as I'm passing data through this model and this schema. Um, in some other languages, you might have to create a um, a connection to the database and then connect to the database you call find in order to do a query, or you call create to create a new document or insert or something like that. And then you can pass it any piece of data. But for Mongoose specifically, they associate all of these methods with a model. So if I call find on this model, I am trying to query any documents of this model type. So any ice cream documents in our database, which right now is nothing. So what is .find? .find is a query that gets a list of documents that match some filter. We're actually not even going to pass it a filter. We're just going to say, give us all of the ice cream documents. And this method, this incredibly long, disgusting thing that no one should ever be able to decipher what the hell is going on here. This is a promise as well. So we can await on this find method. And we're going to make this function async so that we're allowed to await. And we're going to return whatever the value is with our ice cream. But database queries are prone to error. You might not be able to connect to the database right now, or you might be trying to find something that's not there. And so this can fail. In the case that this fails, we're going to return an empty array. So what is this going to do? This is going to return us an array of all of these different models. Or if we can't find any, then we're just going to return an empty array. So that's one piece. The other piece is we need to actually save our ice cream. Or specifically, we need to be able to take some scoops away and then save it. So what are we going to do? We're going to say this flavor our result. We're going to try and This also needs to be async. We're going to find one, which means I only expect there to be one document that matches my filter. A filter we specify with an object and then a set of key values that we want to match. In this case, I want to match my flavor. This is the key on my ice cream model flavor. And this is the parameter here, which will be some string, vanilla, chocolate, mint chocolate chip, strawberry, so on and so forth. Because these are the same thing, we can do a convenience and just specify the variable. It will insert a property on this object named flavor, and the value is whatever's in this variable. So those are equivalent. And we are going to await for this, and we're going to assign it to response. So if it is successful, we're going to assign our data here. Let's call this ice cream instead. And again, this could fail. If this fails, we're going to return an error string. Let's return failed to get ice cream from database plus our error text, whatever that is. All right, so now we have our ice cream. The reason why we did this is because this ice cream result otherwise would be limited to this try-catch scope, but I actually want to be able to use it past my try-catch. I shouldn't have to put all of my other logic that doesn't have the possibility of failing into a try-catch. So all we want to do here is take this ice cream. We no longer have to iterate through an array because we just have our ice cream. And we called it item previously. Let's actually just call it item here for simplicity. So we no longer are worried about our flavors not matching. If we get a response, if we get something back, we know that it matched. Otherwise, it was an error, and then we're going to return an error string. If our available scoops, so again, this is item.scoops, which gets this field from our schema. And if we do not have enough scoops to match what someone is trying to buy, then we're going to return a string. They wanted to buy this number of scoops, but we only have this much in stock. Otherwise, we're going to say item.scoops, subtract away how many they bought, and we need to save the updated document back to MongoDB. So how are we going to do this? We're going to call item.save. This can also fail. We're going to put this in a try catch. Return fail to save updated ice cream stock and attach whatever error occurred. So this saves its document back to the collection, either by inserting it if it didn't exist or by updating it, which is what we want here. And if all of this succeeds, then we know that we have actually let them buy ice cream. And so we're going to return an empty string here. All right, this is our business logic. So what are we going to do? We're going to go into our routes, make sure that we don't have to change anything here. So if we have our controller logic, we're going to split screen this. So our controller logic we just updated, these are now async functions because we need to await for the result for anything MongoDB. Then this get, which calls our get stock function, this needs to await for the result since it could take a long amount of time. And only once we get that result back are we going to share it, which means that this handler has to be async. Similarly, when we post, which means I'm trying to buy ice cream. This will need to be async. And we're going to go down to where it calls buy ice cream, passing in flavor and scoops, and we're going to await for this. And once that's finished, if there was an error, so if that string is not an empty string, if it was this or this or this, then we're going to return a 400, which says you did something wrong. Otherwise, we're going to return a 200 error code, which indicates that everything was successful. All right, this is not quite enough to really test our application since we have no way to populate our database, which maybe we should have done that first in hindsight. But we can fix this pretty easily. We're going to create a new route. We'll make this patch so that it's different than the methods of these other two. And what this is going to do is it's going to update the number of scoops in our database. Is this exactly how I would design an API and give it to my team at work? Probably not. I think there's maybe a couple of problems with this. Number one, like the semantics of patching usually indicates that I am setting a value of a document to a new value. But if I'm saying I just purchased for the store 3 new containers of ice cream, and we now have 30 more scoops that we can offer. I didn't know how many we had in stock previously. I'm just adding more. So this maybe isn't quite the right fit, but we're going to use this just for simplicity. And we're going to keep a lot of this the same, where our patch request is saying we're going to add a certain number of scoops to a particular flavor. So it needs to have both of these options. And instead of buy ice cream, we're going to add to inventory a certain flavor and a certain number of scoops. And we need to write that function. Async function, add to inventory, flavor, scoops. We're going to export that, which means we are actually able to call it and import it up here. And what are we going to do here? So we have our flavor and our scoops. We are going to mostly copy this, actually. So we're going to get whatever our ice cream model was previously. Once we have that item, we're going to instead add to the number of scoops, and then we're going to save that. And that's it. That's our whole function. So all we're doing is we're adding a certain number of scoops to whatever was there previously. There is another way that you could do this that's a little more complicated using the MongoDB add function. This is an operator where I can say add actually, this is not super helpful. I don't think this is what I want. Anyway, we could create these really complicated MongoDB statements that say take whatever the previous value of, I think it's inc instead, increment. Yeah, so we can say take whatever the field was and increment it by a certain amount. So we're going to update whatever ice cream was there, and we're going to increment the quantity by -2, which is subtracting, or in our case, we could say get the ice cream of name vanilla and increment the number of scoops by whatever. I think this is maybe a little bit more complicated, so we can maybe do that afterwards, but we're going to leave this for now just to make the copy and pasting easier. And now that we have that, we're going to go into our routes and make sure that we're calling it correctly. I think there's a problem here. Ice cream imported from controllers. This is going to be ice cream.js. And now our application is running. So we're going to prove that this works. I see that there's a chat message. I will look at that in 1 second. But I want to validate that this works before we go any further. So I'm going to pull up MongoDB, Compass, and Postman. Postman we started using last week to save API requests that we're going to make a lot. So we saved our get, which gets our current stock. We saved our buy, which purchases a certain number of scoops. And then we created, or I created rather, a patch request earlier that calls that URL. And it is going to purchase a specific flavor and a certain number of scoops. Actually, I don't think that this is going to work the way that I want it to. We're going to try it anyway. I think we're going to see that this doesn't work, and we're going to see why in just a second. So right now we have no stock. If we try and get, it returns empty since we have nothing. If I try and buy from vanilla, we're going to get back that we wrote a bug. Controllers, ice cream, line 19. All right, so item is null, which means this find one gave us a null value. So there wasn't an error, but item being null indicates it's not in our database. So if item is null, then we're going to return flavor not found is not in stock. Let's do that. So now if I call this again, we've handled this properly where flavor is not in stock if it's null. So only if it's not null do we want to actually check the number of scoops and update things. And that's, I think, what we'll need to fix about this patch function. If I try and call this right now, where we patch by adding 15 scoops of mint chocolate chip, I send it, we're going to get that same can't get properties of null. Because we try and get the item, we find that it does not exist, and then we try and add scoops to it, but we can't do that because item is null. So if item is null, then we're going to say ice cream model dot create. And then we're going to pass it in the object that we want to create. So we're going to create a object with flavor and with scoops. And we need to try catch this. So if we can't create it successfully, something went wrong and we weren't able to do that. If it was successful, then we're going to return an empty string to indicate that this did not work. I'm going to actually extract this to a helper function. Turn insert new ice cream flavor scoops. So this is an async function. If it's successful, we'll return our empty string, otherwise our error message. So we're just basically taking away a bunch of code that looks really gross. We're sticking it into a helper function, and we're naming this function exactly what it's doing so that our reader is pretty clear on what's happening. Let's try it again. Now, if I patch, it was successful. Now, if I go get my stock, I now have 15 scoops of mint chocolate chip, which is great. I could patch it again, add 15 more scoops. Now I have 30 scoops. I could patch strawberry and add just 5 scoops since people don't like strawberry as much. And now I have 30 scoops of mint chocolate chip and 5 of strawberry in my inventory. And if I want to buy 1 scoop of vanilla, we don't have that, but if we want to buy 1 of strawberry, that is successful. And now we only have 2. Cool. So that worked. And if we go back into our application, we'll see that we have 30 scoops and 2, which is correct. And the part that we wanted to get to this whole time, if I stop my server and I start it back up and I go back in, we still have the same amount of things. It is now persisted in MongoDB. If I were to refresh this, we now have this database of ice creams, and it is where all of our stuff is living. And it will live there until I delete it or until I update it from my application. So that's the point of using a database. You guys are going to do something more complicated for your Task Manager API if you haven't already. But this is just basic introduction to MongoDB and Mongoose. All right, that's all I got. I see a question in the chat. Not a question. I had to leave a little bit early. That's okay. I will stick around for a couple minutes for any questions, follow-ups, anything you guys are curious about. Otherwise, just make sure you sign in before you leave so I can take attendance and upload the recording later tonight. Sorry for moving really fast. This is a hard lesson just because there's a lot of setup. I will do my best in the next couple weeks to make it easier to follow.
Okay, really complicated. When we try to can delete from the database, do we delete from the Mango database?
Yep. So our MongoDB database, which I have running locally, or you could use MongoDB Atlas. This is where all of your data is living. As long as your server is running, it is accessible, and that data, you can stop it and start your MongoDB instance as much as you want. It is stored somewhere on my computer, very tightly packed away in a very smart way, such that it's very, very quick for MongoDB to go look it up. And that's where all of our data is living until we do something with it. It will not go away if MongoDB restarts. It won't go if our application restarts, anything like that. Other questions? All right. Well, I'm going to call it here. I'll upload the recording by the end of the night in case people want to go back through it in the future, since I did go very fast, and I apologize for that. Feel free to reach out with any questions as things come up this week. If you get stuck on something, I'm always happy to help. Just send me a
Did you record it?
I am recording. I will stop the recording and I'll upload it before the end of the night.
Oh, okay. Thank you.
No problem. All right. Have a good night, guys. I'll see you next week.
Thank you. Bye.